Now, the study of stress took a second step forward when stress itself on a longer timescale became a legitimate research subject. And this arose and was noticed first by the pioneering researcher, the physiologist Hans Selye. Now, Selye was interested in stress, and he thought that stress was the body's response to deviations from the set point. And he pioneered the understanding that the stress response was mediated by these hormones called glucocorticoids, these hormones that act on a timescale of minutes to hours, and they mediate the stress response. Now, the way that Selye did this, he did his work in the first half of the, and part of the second half of the 20th century. He was trying to study the effects of an ovarian extract on rats. And he, like many researchers, used rats as his model animal, and he would use them and observe their behavior. And when you handle rats, you have to catch them, you have to inject them. And the thing he was trying to find out was what a particular ovarian extract did to a rat. And so he'd run around the lab, and sometimes they'd get away. This is commonplace in animal research, that you have to catch the rat and then inject the rat with the thing you're trying to test. And what Selye was trying to do was understand what an ovarian extract did to these rats. And what he found was, after injecting these rats, he found peptic ulcers in the stomach, he found enlarged adrenal glands, and he found shrunken immune tissues. And of course, he was pleased to get a result. He was very interested in finding out what this extract evidently did. And then, like all good scientists, he did a control experiment in which he injected, instead of ovarian extract, he injected just saline. And much to his surprise, when he injected saline, he got the same effects: enlarged adrenal glands, ulcers, and shrunken immune tissues. And that was curious. He got the same effects when injecting something that contained no active principle, the saline solution. He also tried putting rats on the roof in winter, so something that involved no injection at all. Putting rats on the roof in the winter, forcing them to exercise much more than they would normally do, and performing unnecessary surgical procedures. All of these things had similar effects: ulcers, shrunken immune tissues, and enlarged adrenal glands. So these are all things that happened with a wide variety of manipulations. And this pioneering work led Selye to put forth two principles that we still study today. And one is that the body has a surprisingly similar set of responses to a broad array of stressors. All of these different events that he subjected the rats to all cause a similar set of responses. And the second thing he found was that under certain conditions, stress will make you sick. It will do things like weaken your immune system. And the general principle that emerges from this is that stress is a response that attempts to restore homeostasis. Its general goal is to keep things the same. And so the general idea is that these responses, such as shutting down the immune system, such as getting your heart rate to go up and so on, these are responses that are necessary for getting away from danger, necessary for conserving resources for something essential. And so, like the fight or flight response, the stress response is also an essential part of maintaining a homeostasis, of conserving resources for getting you out of a situation that you're in.